first one on the sheet. And he has a trick to him. Not right away, but he does show up. You'll see it in a little bit. All right, let's assign oxidation numbers. That's the first step. We'll do that quickly. There really aren't any hard oxidation numbers to do in here. I and K, neither one of them are a rule, but they both have the common oxidation states of +1 and -1. No surprise. O is -2. H is +1. Therefore, S is +6. By the way, you're going to start to find, as crazy as it is in Chem 1, when by the end of the year you knew oxygen was 15.999, you know, and you knew the charge of sodium was +1 and H was +1 and O was -2. You're going to start to know the charges within a polyatomic ion of these guys. You're going to find that sulfate shows up so many times that S is always +6 whenever you see a sulfate. All right, -2, +6, +1. Iodine, by the way, by himself is 0, +1, -2, +1, -2. Okay, everybody got those? All right. Where? That's a 2. It's a 2. I said -2. I have the video evidence of me saying -2. All right, I is got a -1, and he's going to I2 with a 0. So we see the same thing we just saw a minute ago. He's going to I2 with a 0. I've got to balance it for mass first and then put 2 electrons over here. Got it? Yep. S with the +6 is going to, here's part of your problem. S with the +6 is going to S with a +6. What? Yeah, there's an S with the -2 though. He's going to go to that one. All right, S with the -2. That takes, 4 electrons, right? 6 minus 2 is 4. 8. It's very easy to make that mistake. 8 electrons. All right. I got 8 electrons gained. I have 2 electrons lost. I'll need a, 4 in front of this guy. Is that it? Yeah. Now, I drag all that stuff down, and I've got quite a few things to put in here when I rewrite this. All right. 4, what do I put in front of the iodine, the Ki? 4, 2, 8. Because 4 times 2 is 8. So 8 Ki plus H2SO4 right now is H2SO4. Oh, wait, not this, yields. K2SO4 right now is K2SO4. Iodine is 4 in front of that iodine. H2S, just the 1. And H2O, he's always the last guy we figure out, it seems. All right, now watch what happens here. This is really, really important, okay? I'll start to balance the ones that are the most obvious ones by inspection. By the way, if you've got this to this point, you've got all but 1 point. All right, so this is not as big of a deal as it seems. However, 8 Ks, I'll need a 4 in front of that. Nobody should get that wrong. But here's the problem. It looks like I'm about to break a rule. The whole point of doing these half reactions, I told you early on, was to get rid of having to worry about balancing the guys, these 4 guys. 1, 2, 3, 4. I don't have to worry about balancing them. I never have to touch those coefficients again. That's an 8. It's always going to be an 8. That's a 1, and it's always going to be a 1. But I'm going to break that rule, aren't I? I'm going to have to. And it's not because I'm really breaking the rule. And let me show you why I'm not really breaking the rule. Okay, I'm going to use yellow. Orange is probably the best one. You'll still be able to see it from the TV. This S with the +6 went to this S with the -2. Here he is. Here's the S with the -2. Here's the S with the +6. So that's all I took care of in this half reaction was the one guy that went there. But what about these other 4 S's with +6s? There's 4 S's with +6s on that side of the equation, aren't there? What am I going to need in front of this guy now? 4 more than what I have, which is a what? A 5. Do you all have a 5 for that? Yeah. Now, I'm not exactly sure if you realize that you look like, you're breaking a rule here, but it sure looks like I am. It sure looks like I am because I already got the coefficient of that. It was supposed to be 1. And here I am saying, no, it's not 1, it's 5. And here's why. Think of it this way. You have 5 S's with a +6. 1, 2, 3, 4, 5. One of them went here. The other 4 went there. You see? And that's why actually not breaking any rules here. I only took care of the guy who went to -2, changed his oxidation state. Got it? All right. Now, erasing all that. I'm still not done. What else do I have to do to balance this guy? Waters, right? I got 5 times 2 is 10 H's on that side. 2 of them are here. So I'll need a 4 there. 4 times 2 is 8. 8 and 2 is 10, right? Okay, good. Let's try next one. Now that was actually one that they did not ask for in the other class, but this next one they did. What number is that one?
2.
Number 2.
Is this number 2?
Yep.
Okay. Again, on my sheet it's different. It's the SO3 one. Find it on here. Okay, I see it. All right, now I'm just looking at this one to see why we would want to do this one. Does anybody have a problem with that one? Because if they did, I'm not going to do it.
Will you tell us?
Oh, yeah, let's just read the coefficients off. Should have been 5, 2, 6, 2, 5. I can't read my writing, but 3?
3.
Yeah.
All right, so we won't do that one. If you guys didn't have any trouble, I'm not going to do that one. Did you have trouble with this one, number 3?
Not really.
No.
No?
That was,
The problem with that one was, I'm not going to do the whole thing if you didn't. The problem with that one was assigning oxidation numbers to this guy. I know several people had trouble with that. Let me tell you what you should do there. We'll just do that and we'll leave it alone. All right? I would use the polyatomic ion sheet, the common ion sheet, and not try to do him all together. Why? Because there's really 2 variables in here. N changes quite a bit. CR changes all the time. So how do I know who to keep for the common oxidation states? Well, I would do the NH4 separately. I know from the common ion sheet that NH4 is a +1 charge. Whenever you see NH4 as a polyatomic ion, that's his charge. He's +1. He must be what? -3. So that's how you know him. I would do the CR2O7 from the polyatomic ion, common ion sheet. -2, so we have -14, CR2 -14 equals -2, right? So what is CR? +6. So that's the only thing that was really difficult about that. However, in that one, I'll tell you what people did wrong. I bet you some of you guys did this wrong too. When you went to do this guy, CR2, I definitely want to do this. This is a +6 here, and this guy is a +3 here, right? Did you do this? CR with a +3, CR with a +6. Did you do this? +3 electrons? Because that would be wrong. How many electrons would it be? 6. All right. And some people in the other class actually put +3, and then they made another mistake, and it ended up coming out right in the end anyway. But you can't count on that. All right. Okay, so no trouble with that one. Let's take a look at.
What are the numbers for that?
What? Oh, okay. All right. Back to the numbers for that one. Number 3. 5. No, wrong one. Hold on. NH4, right? Okay. 1, 1, 4, 1. Okay?
Yeah.
All right. Now, how about this guy? You have trouble with that one. That one was the most, people had the most trouble with. And I don't know if you guys did or not, but this is the one most people had a question about. Why? Because it's a peroxide. And I definitely want to do this one from beginning to end. It'll maybe the last one I do if you have no other questions. It's a problem that happens. I told you, I've been warning you, it's going to happen. Where you're bringing down the subscripts most of the time, but not all the time. Just like a minute ago, I said, well, you always have to keep this coefficients here, but there are exceptions where the same guy is over there in different places. Same thing happens here. I don't have to keep one of these subscripts when I rewrite them, and you'll see what I mean in a minute. All right, first off, let's just do the oxidation numbers. If I know he's a +3 because he's a -1 for the whole thing. -2 + 1, -2 + 1. Peroxide, +1, -1. Oxygen, one of the rare cases where he's not -2. -2 + 6. And -2 + 1. All right?
Yeah.
Okay. Chromium's going from CR with a +3 to CR with a +6. And that takes 3 electrons. Y'all do that? And hydrogen peroxide, the O is going from O2 with a -1 to, this is the mistake. Everybody watch. Okay? You actually can do this, get the right answer by reducing at the end. But here's the problem. I do not need to write O4, which a lot of people probably did on this side, bringing down a subscript. Let me explain why. I told you a little while ago, the first time I covered this, is that you have to bring the subscripts down when you're doing these. And that's true if they're only in one place on that side of the equation. I only have one place where I have an O with a -1 charge. One place, right there. All the other O's over here are -2s. So I have a choice. That has to be a subscript of 2. I have no choice in the matter. However, it's going to turn out that O with the -1, all the ones that went over here and were actually reduced, okay, those guys could have gone here or here because I got O's with -2s in more than one place. So I'm not limited to a subscript of 4. Some of those, you're going to find out, some of these guys went here and some of those guys went there. All right, that can happen. All right, so I'm not limited. I do have to balance it at least for mass that much. I have to have at least 2 O's over there. And that means that it has to be at least how many electrons transferred. See why? -2, -4, okay? And this guy is, and I haven't written this down in the previous one, but you should always write down which is oxidation, which is reduction. Okay. Is this guy balanced? No. I need a 2 in front of this guy, 3 in front of that guy, right? All right. I transfer everything down, and let's watch what happens. Watch. 2 goes in front of this guy. CrOH4 with a -1 charge. The OH, I don't know. Not yet. The hydrogen peroxide, I do know. It's a 3. Now, here's where the mistake's coming up. Watch this. The CrO4, that has to be a 2. I know that because the 2 has to be in front of this guy. So 2 CrO4 -2. But somebody's going to say, okay, so I need a 3 times 2 is a 6 in front of that guy. No, I need a total of 6 oxygens on that side. Okay? Okay, I need a total of 6 oxygens on that side that came from 3 times 2, that have a -2 and came from over there. Some of them may have gone here, some of them may have gone there. So I don't have to use that 3 anywhere yet. I'm just going to put water down. Okay? All right? Make sense so far? Okay, let's see what happens now. Well, I would balance this guy for charge next, I think. There are no other elements that are clearly wrong. I have my chromiums taken care of. I have my peroxides taken care of. So I'm going to basically start looking at the charge. I've got a total of -2 here. I have a -1 there. I've got on this side of the equation, a -4, right? What can I use? I can't change him. I can't change him. I can change him. What could I do to balance out for charge? 2 in front of there. Okay, a 2 in front of there would give me a -4, -4. Got it? Last thing to do. Everybody's now taken care of. Look, all these coefficients are looking good. We just got to make sure that our O's are okay. And H's. O's and H's. So it doesn't really matter which one you look at because they'll both come out the same in the end. Let's look at the H's. 2 times 4 is 8 H's. 2 times 1 is 2 H's. 3 times 2 is 6 H's. So how many we got here? 16? 16 H's. What do I need in front of the water? 8. Now you may have gotten that, but did you have a mistake up here like other people did? Maybe? I don't know. Over here, did you use a 4? If you used a 4 here, you could still get the right answer, but what would happen is you'd probably end up having to reduce your coefficients at the end, is my guess. All right, that's all the examples I wanted to do.